So let's just kind of recap. What is the fundamental counting principle? So the fundamental counting principle is like, okay, if there's A ways of doing one thing and B ways of doing something else, then there must be A times B ways of doing them both together, okay? So then how do we approach the fundamental counting principle? Anytime we have to make a decision, anytime there's a selection to be made, anytime you're arranging something, that's how many dashes you would draw. And then the operation in between is multiplication. And then the number of options available to you for that particular spot goes on top of the dash. So let's just kind of recap a couple of the questions right in your notes. Like, so when we were talking about 5-character license plates, if the first 3 characters were letters and the last 2 characters were numbers, and the first letter had to come from P, W, Q, E, L, or K, this is how we would set that up, okay? And then we started exploring this idea of without repetition. If it's without repetition, the same number cannot be used twice, okay? So we had dealt with this idea of, okay, well, what happens if I'm, ordering from a menu? And we dealt with a lot of examples, and this was last Wednesday, which is like so long ago, so I want to jog your memory. And then I showed you what factorial notation was, okay? Today we're going to algebraically play with factorial notation. But before I do that, let me just see where we're at here. That's where we're at. Okay. Before I do that, what if I asked you how many 4-digit numbers, actually let's say how many, let's do this. How many odd 4-digit numbers are there? Okay, so just quick recap. How many 4-digit numbers are there? How would you guys approach this, showing all the necessary work for a fundamental counting principle? How many dashes should I draw? 4. Okay. So 1, 2, 3, 4. What number should go on top of this dash? What number should go on top of this dash? So there's so many details here that we have to attend to. Yes, 0.
5.
Which one? The left or the right? Yeah. Okay, so guys, this, if it's going to be odd, it had to come from the set of 1, 3, 5, 7, or 9. Those are the only digits. So on the end, this can be even, this can be even. It's only the last digit that has the restriction in terms of the odd, right? And then what's going to go here? 0, what do you got?
9.
Okay, that's going to be 9. Why is it 9?
Being number but 0.
Not 0. Guys, if it's a 4-digit number, if we start with 0, it's not a 4-digit number. It's a 3-digit number. Okay? Now, what number would go right here? It didn't say without repetition. So it's got to be 10, and it's got to be 10, right? And so this would end up being like 4,500 4-digit numbers in total. Sorry, 4-digit odd numbers in total. Now, what if I did say this? How many odd 4-digit numbers are there if the digits must not repeat? Always deal with this restriction first. Okay, so we still have a 4-digit number, but I've changed the wording a little bit. Now remember, we're going to be using our highlighters. Like we're going to remember to highlight this. We're going to underline this, right? Oh my gosh, there's no repetition. How am I going to dive in? How is this going to look different? Is the without repetition going to impact this spot right here? What should go here? It's still 5. Okay, so We're pulling from the set of 1, 3, 5, 7, and 9. Right? How many options do I have here now? Do you guys see the 8? It can't be 0, but it also can't be this digit. It's got to be 8, right? Okay. Now what goes right here in this spot? A lot of people are thinking 7, but the correct answer is 8. Why is it 8? Now the 0 can come back into play. Do you guys get that? So when you're thinking about this, okay, so you've got your 1, 2, 3, 4, 5, 6, 7, 8, 9, and we've got our 0 here. This first one came from one of these, right? So now you have to pretend like one of them is gone, right? And then the next one came from anything but the 0. So then there was 8 options. So let's say we selected that, but now the 0 comes back into play. Do you guys see that? So sometimes like just laying out, if it's without repetition, laying out those digits is really nice. And so this becomes 8. And then now, it doesn't matter. I've selected one of the others. I'm left with 7. Notice the difference between the work that's shown and that just that slight variation. Like every question becomes a problem-solving question. Okay, now we're going to dive into the permutation formula. And we talked about factorial notation. And if you had like 5 factorial, that means you're taking, it's called the product of descending consecutive numbers, whole numbers, to 1. Okay? So when you look at your formula sheet, this is the last like section of formulas. This is your n is an element of the natural numbers. You're not going to like put like -7 factorial. That's not a thing. It's a descending product of natural numbers all the way down to 1. So if I say 5 factorial, this would be 5 times 4 times 3 times 2 times 1. Now sometimes the math requires us to see a 0 factorial. 0 factorial just needs to be 1. Now this is actually something called the permutation formula, and it includes factorial notation. So if I have 5p3, the formula would be 5 factorial all over 5 minus 3 factorial. You need to figure out the brackets first, and then you deal with the factorial. Guys, what's 5 minus 3? Okay, so that's going to be 5 factorial divided by 2 factorial. Now, in 30-2, you would just type this into your calculator. In 30-1, you need to know how to work with factorial notation. And if you actually expand this, this becomes 5 times 3 times 2 times, except I missed a 4. You guys all saw that, right? Like I'm like skipping 4 entirely. 5 times 4 times 3 times 2 times 1. And then 2 factorial would be 2 times 1. And we'd end up with 5 times 4 times 3. And that's how we're going to work with the permutation formula. It's going to have factorial in it. And that's what we're going to learn today, is learning how to work with the permutation formula. Yeah?
Would you just leave it like the 5 times 4 times 3 for the
You'd end up figuring it out.
Oh.
In your calculator, okay, so guys, 5 times 4 times 3, I'll show you, like, if I put 5p3 into my calculator, so everyone type this in, because you don't know these buttons. These are new to you buttons. Push 5, and then go to Math, and highlight PRB, and then you're going to go to NPR. So we've already done factorial. Go to NPR, and then type in the 3, and it gives me 60. Why does it give me 60? Because that's 5 times 4 times 3, and it gives you 60. So in Math 30-2, you would just type this into your calculator, and you were done. In Math 30-1, we have to work algebraically with the factorial notation. Okay? So yeah, you would actually put down 60 here. Okay, I am going to come back here. So, and this is a situation where we've got 5 children. We were lining them up to take a photo. And so there was, remember, people can't repeat. Like a person cannot be in 2 different spots at the same time. So this is a 5 times 4 times 3 times 2 times 1, 5 factorial situation. When you look at the NPR formula, N represents the number available to you. R represents the number you're going to arrange. So if there's 5 children available to us and we're arranging all 5, When I use the formula, this is when you can see the 0 factorial being necessary. Okay? 5 minus 5 is 0, but we end up with 5 factorial. This would be a way of representing this situation. This would be a way of representing this situation. And fundamental counting principle would also be a way of representing this situation algebraically. Okay, let's just do a few of these so I can send you guys to whiteboards. Okay, without your calculators, we're going to evaluate these. What's 3 factorial mean? That's 3 times 2 times 1. It would be 6. I want this. I don't know why I did this. I have the same thing written twice. Do you guys see that? We're going to fix, I'm going to give you guys something different there. Okay? Now, if you were going to figure out 10 factorial over 8 factorial without your calculator, that seems pretty mundane because it'd be like 10 times 9 times 8 times 7. But watch this. When I see that the 10 is bigger than the 8, okay, I'm going to recognize that if I start to expand the 10, I'm going to stop here because it matches my denominator, and 8 factorial can divide 8 factorial. So I don't have to go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Like you could put times 7 times 6, and then the 8's divide, the 7's divide, the 6's, or we could just 8 factorial, and we end up with 90. So let's try this one. What if I had 8 factorial divided by 6 factorial? Work on the larger number. This would be 8 times 7. As soon as it matches your denominator, we can divide our 6 factorials. Guys, what's 7 times 8? Okay, now check this one out. I'm just going to put it below. If I had 9 factorial over 11 factorial. So the bigger number is actually on the bottom. How would we manage this? We still expand the bottom. Leave the 9 factorial alone. This is 11 times 10 times 9 factorial. 9 factorial divides 9 factorial to make 1. So we end up with 1 over 110. 11 times 10 is 110. And then we would just have the 1 on the top. You expand the bigger expression. Yeah.
Would this be considered full marks then if you did the factorial on the top and then you divide by the factorial on the bottom?
Like this?
Yeah.
You're never going to get this easy. I'm just, so you're, on a test, you're not going to get something that's like this because you could just fire it into your calculator. What we're going to do is we're going to start working with the expressions, with the variables. Okay? So, we're just learning how to work with factorial. Now, when you're dealing with the variable expressions, the question you have to ask yourself is which is bigger? Because sometimes people don't conceptually understand which should be bigger. Which is bigger, n or n minus 1? N. So you always work on the bigger expression. So when I'm asked to simplify this, my n factorial, what's 1 less than n? N minus 1. This matches my denominator now. And then n minus 1 divides n minus 1, and my simplified expression is just n. Did you guys see that? So we have to work with the variables because we're going to take it to the equation. Which one's bigger, a minus 1 or a minus 2? Okay, what's 1 less than a minus 1? What's 1 less than a minus 1? A minus 2, right? They match, it matches the bottom. And then I can divide, and my final expression is just a minus 1. Do you guys want to think, like, what's 1 less? What's 1 less? What would an expression for 1 less be? Okay, which one's bigger, n plus 1 or n minus 1? What's 1 less than n plus 1? N. Okay, just let that sink in for a second. Do you see that one less, like if I put n plus 1 minus 1, we'd end up with n. Like you guys get that, right? And you could show work if you want, and then take one less than that. So now that they match, now that the n minus 1 factorial pairs the n minus 1 factorial, my simplified expression is n squared plus n. Okay, so you have to be able to work with factorial notation with the variables. And this goes beyond 30-2 curriculum. Is that the last one on this page? Okay. Now, on the next page, we're actually going to solve equations with factorial notation. And when you're solving those equations with factorial notation, I want you to set a goal. This is your goal when you're solving those equations. Variables with factorials on one side and numbers with no variables on the other side. So that's how you're going to start. You're always going to think, I want all variable factorials on the same side, and I want all numbers without variables on the other side, which is kind of standard when solving any equation anyway, right? We put variables on one side, we put non-variables on the other side, and then we'll see what we come up with. So when I look at this guy right here, this should be pretty standard. I can simplify this expression. I'm going to solve this, remembering that n is an element of the natural numbers. And by definition, if we're saying that n is an element of the natural numbers, anything that's not natural has to get rejected. Okay? So when I look at this one, I can see that this is the bigger value. So that's the one I'm going to start expanding. This is going to be n. 1 less than n is n minus 1. 1 less than that is n minus 2. And now, these match. And we're going to start solving this equation. We're going to distribute the monomial through the binomial. Where do I go from here if I'm solving this equation? It's solving a quadratic, guys. So now we're going to n squared minus n minus 6 equals 0. Now, some people are like, Sakura, these are two consecutive numbers that multiply together to give me 6. Could I just say n equals 3 times 2 and get the 6? Not algebraically sound. So you actually have to do the algebra. I know that intuition, particularly for a question like this, is quite helpful. Like I would basically use intuition at this point, be like, okay, two consecutive numbers that multiply together to give me 6, 3 times 2, I know n is equal to 3, but you have to show the algebra. Yeah.
Other restrictions?
So yeah, so by definition with factorial notation, the restriction is n has to be an element of the natural numbers. So and that's actually on your formula sheet, and it's always implied. Okay, so it's on your formula sheet, it's a definitive. When you're dealing with factorial notation, whatever n value you get has to be a natural number. So when you're solving this, this becomes n minus 3, n plus 2 equals 0, n minus 3 equals 0, n plus 2 equals 0, n equals 3, it's natural, I keep it, n equals negative 2, unnatural, it's an integer, it's negative, and it's an extraneous solution, and it's only because we defined n as always having to be a natural number. Okay? So they're going to get a little bit more complicated, and you just need to keep thinking to yourself, I want any variable factorial expression on one side and any non-variable factorial expression on the other side. Okay? So when I look at this question, you guys have to recognize that 3 is not a variable. Guys, what is 3 factorial? 3 times 2 times 1. This is actually 6. So that's not a factorial at all. How would I move the 6 to the other side? Divide by 6, right? So I'm going to divide by 6. Whatever I do to one side, I do to the other side. Now, 72 divided by 6 is 12. Now, which one's bigger, n minus 1 or n minus 3? N minus 1 is bigger, so I'm going to start decreasing that so that it pairs with the denominator so that I can cancel it. So the tough part is people don't recognize the 3 factorial as a constant that needs to be moved to the other side. Now that my factorials are canceled and gone, I'm solving a quadratic. So n squared minus 3n plus 2 equals 12. Get 0 on one side. Don't lose any of the details. N minus 5 equals 0. N plus 2 equals 0. N equals negative 2. Reject it as extraneous. Just because n has to be an element of the natural numbers. And then n equals 5 is your only correct answer. Yeah? Okay. This one is way trickier because of the way it's laid out. So what do you want to do? You want to put any variable factorial notation on one side and any non-variable number on the other side. Do you guys see that 3 factorial is just the number 6? Do you guys see that 5 factorial, 5 times 4 times 3 times 2 times 1 is just 120? Are you guys okay with that? Okay, so all I'm going to do is I'm going to recognize that these didn't have variables on them, so I'm going to get rid of those factorial expressions or the factorial notation on the 3. And then I've got 120 n minus 1 factorial on the right. How do I move, like which one, what do you want to move? Do you want to move the n plus 1 or do you want to move the n minus 1 to the other side? I would want to work with numbers, not fractions. So I'd probably start out and I'd be like, okay, I'm going to move the n minus 1 to the other side. Whatever I do to one side, I do to the other side. That cancels it. I'm going to move the 6 to the other side. Whatever I do to one side, I do to the other side. And what we're ending up with here is I've got this expression. All my factorial notations are on the left. And I've got a single integer on the right. Can I get you guys to expand the left-hand side to remove and simplify your factorial notation? Guys, what's 1 less than n plus 1? Don't forget that there's an n there, right? And then you can pair it with your n minus 1 on the bottom. And you're not skipping steps at all. Guys, make sure you reject the negative 5. I kind of skipped steps here because I thought I was running out of room and I shouldn't have. Okay, so you had like x plus n plus 5 equals 0, n minus 4 equals 0, n equals 4, we keep this guy, n equals negative 5, we reject it as extraneous. based on the restriction that n always has to be a natural number. Yeah? I'll just kind of zoom out. Is there anything about these factorial notation questions where you're like, oh, secure, I don't like it? Are we okay with that? Okay, go to the whiteboards. We got 5 minutes to whiteboards. When you see NPR, a permutation is an arrangement of distinguishable objects. Okay, so you're arranging the objects. If I moved you guys around, that's a different permutation. Even if you're all four of you in the same row. If I just switch Adelaide and Hannah, that's a different permutation. That's a different arrangement. So N is basically the number of elements that you're arranging. Like that's how many you have to arrange. R is actually the number you're going to arrange. So you have a set of N elements, but you're only going to arrange R. So this is your number of elements. This is the number to be arranged. So when you look at this question, how do we actually like figure this out? Remember that order matters, okay? And we're just going to do one more example. We've got 1 minute left. It says how many 2-digit numbers can be made from the digits 2, 3, 4, and 7, and 9 if no digit can be repeated. We can use the fundamental counting principle on this, but I'm also going to connect it to the permutation formula. As soon as there's a no digit can be repeated, you can use this formula, and you need to know that you could have used that formula. So if it's a 2-digit number, if we can only use those digits, how many options do I have here? There's 5, and then there's 4. So this would have been 20, and this would have been a brilliant way to outline this question. Another way of representing this is we've got 5 digits presented to us, but I'm only going to place 2 of them. So using the permutation formula, this is basically your number of dashes. And this is your number of options. And I'm going to finish this, guys. So 5 factorial all over 5 minus 2 factorial. So 5 factorial over 3 factorial. This would give you the same thing as the fundamental counting principle. So I just need you guys to recognize that this or this would be suitable for this question. Okay, there's no bells today, so 10 o'clock was the end of class. So that's the end of class. We're going to finish lesson 11.1 tomorrow. We're going to finish lesson 11.2 on Wednesday, Thursday, and then we're going to be finished this whole unit next Monday, and the test is next Thursday, I think. Let me just double check.
That's so crazy. Like, wow, that means that we plan on actually. Oh my gosh, this Sakura.
Give me 1 second. I just want to see. When's the test? Unit 3 exam rewrite? I didn't actually indicate the Unit 4 exam. Yeah, thank you. Okay.
This morning.